Hello. So this is the last example of this chapter. So we are going to consider an example of COVID-19 vaccine effectiveness. So suppose that you yourself developed a vaccine for COVID-19, which is very effective. So you believe that the vaccine builds antibodies with probability 80%. So it is effective with 80%. 80% of like vaccinated can be protected. And also you want to test it. 80% is the parameter you want to test. You believe, so the null hypothesis is your belief. You believe the probability of antibodies, having antibodies is equals 80%. And the alternative is the negation of that. And of course, P is the probability of having antibodies after vaccination. So how do we collect data? We are going to choose a random person and give a vaccine to the person, and then we observe after the vaccination. We do an antibody test and see the result. X is a random variable defined this way. X takes 1 if the person developed antibodies, but if not, 0. So 1 is success, 0 is failure. And in this case, again, this is a binary distribution. So remember, in binary distribution, the probability of success equals population mean. So you may use the methods for population mean in this case, like by interpreting the parameter as a population mean, right? And another thing you have to remember is this. We used it in the previous chapter too. So the standard deviation in the binary distribution is given by this formula. P times O minus P. Probability of success times probability of failure, and then that's the variance. So take the square root. That is how you calculate the standard deviation. We are going to use this. By the way, this exactly has the same structure as what we did at the end of the earlier chapter. We considered the Obama like presidential election example, and at the time we used this structure again. But this time there is an additional difference. So like stay focused. And now what I'm going to do here is I'm going to assume that my belief is true. So that's how we start and to calculate the null distribution. And then the additional difference is this. If you believe your hypothesis is true, then it also implies a specific standard deviation because the standard deviation depends on the probability P, which you believe to be 0.8. You believe probability is 80%, so from that, your standard deviation must be 0.4. This is similar but different. So you do not use the data to calculate the standard deviation, but you have to use the belief again in this standard deviation using this formula, right? So the idea is natural, like, right? So this standard deviation will be used to approximate the sampling distribution, right? So remember, the sampling distribution is based on your null hypothesis. Earlier, we calculated standard deviation from the data because at the time, the parameter, your belief, has nothing to do, does not imply any specific standard deviation. Now, your belief implies mean of 0.8, standard deviation of 0.4, and the sample size will be given when your data realize. So far, I only used the null hypothesis and binary distribution structure. So you additionally only need the sample size to calculate the sampling distribution. So now, suppose that you observe 100 patients or 100 people who got the vaccine, and antibodies are found in 75 people. Now you find the p-value. Can you do it? I skipped a lot of steps, but I believe you can do it. Right? Okay, just in case if you have no idea where to start, I will give you the idea. First, you have to calculate the t-statistic and then apply the t-statistic to the standard normal distribution, calculate the p-value. And in calculating the t-statistic, basically that's about the difference between the sample, the observation, and your hypothesis. Your hypothesis is 80%, but your observation tells you 75%. So you check the difference and standardize it. That's the t-statistic. And once you get the t-statistic, p-value is the probability on both sides, outside probability on both tails. So you can calculate the p-value from Excel. Okay, let me show you the answer. So t-statistic goes this way. 75% is what you observe, 80% is what you believe, and standardize. Using the standard deviation, we calculated based on the formula. Sample size was 100, and then t-statistic is minus 1.25. Then p-value is the probability smaller than minus 1.25 and greater than plus 1.25, right? Both sides. As a result, if you use Excel, you can find 21% is the outside probability, p-value, right? So then p-value is 21%. That means it is from the top 21% ranking in the, like if you rank from the most unlikely outcome, it is top 21%. So among those significance levels, when can you reject this outcome, this p-value? So remember, the null hypothesis is rejected if the p-value is smaller than the significance level. But none of these significance levels is greater than the p-value. So p-value is always greater than the significance level, so it will never reject it. So the answer is none. It is not rejected. So if you reject top 10%, then top 20% will survive, right? Intuitive. And now try the critical value approach. Find critical value approach when the significance level is fixed at 5%. So again, the idea is you have to calculate the margin. And in calculating the margin, standard deviation is from the binary distribution formula, and 5% implies 1.96 z alpha over 2 value. Then plug that in, 1.96, 0.4 standard deviation, sample size 100, and center is 0.8, your hypothesis. So your hypothesis plus minus this much margin. That means you believe 80%, but in the test you allow plus minus 7.84 percent point. Then do you reject or not? You observed 75%. So it's easy. 75% lies between these two numbers. So you choose critical value like this, and your data is inside. So if your data comes inside the interval, then you do not reject. So the answer is you do not reject the null hypothesis. Okay, so to do it again. By the way, as a comparison, when you calculate the confidence level interval, so remember 75% was the sample average. That was the center of the confidence interval. And you used it to calculate the standard deviation at the time, right? So you have to match those two guys in either confidence interval or critical values. So you have to understand what you are based on. What based on like either from your belief, your hypothesis, or from the data. So depending on that, you choose the correct numbers in here and here. Okay, so this example is another illustration of the null how we calculate the null hypothesis and how we utilize the hypothesis. And in the next chapter, we are going to study additional topics about hypothesis testing. The framework for hypothesis testing is so different from everything else in statistics, so it takes more time, and still I think there are not like I could not find any good textbook explaining the idea behind it well. So I hope you understand the intuition, what we are doing and why we are doing this way, and then in the end the formula is pretty simple. So but if you understand the intuition, I believe it won't be that complicated. Okay, so thank you for watching through all the videos. I have a nice week and see you in the next chapter.